Here are a couple more integration by parts problems where you can use tabular because it's x to a power times either cosine or sine or e to the x. But it's a little more complicated because it's not just cosine of x, it's cosine of 5x. So we have to be slightly more careful with our antiderivatives. I'm still going to do the same sort of thing. I'm going to make my u table. My u is x squared, right? Because and then derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 2 is 0. For my dv, I'm starting with cosine of 5x. Now the antiderivative of cosine of x is sine of x. The antiderivative of cosine of 5x is sine of 5x divided by 5. And the antiderivative of sine of 5x divided by 5 is negative cosine of 5x divided by 5 times 5. Right, there's another 5 down there, which is over 25. Let's probably start 5 squared, that'd be better. And then, and it's good to keep these in line with each other. And then the antiderivative of negative cosine of 5x is negative sine of 5x. Then I'm going to divide by another factor of 5, so 5 cubed. So every time you integrate something with a multiple of x, you're going to divide by that multiple of x. So our answer, right, we're almost done. Remember, it's plus these two together, minus this times this, plus this times this. So I'm going to get, and I'm going to fix the signs as it was. I'm going to get plus x squared times sine of 5x over 5. Minus 2x times negative, so that's going to be plus, right, because it's a minus of minus. 2x times cosine of 5x all over 5 squared. Plus 2 times negative, that is a negative sign, sorry. 2 times negative, so that's going to be a negative overall. 2 times sine of 5x all over 5 cubed, which is 125, plus c. Not too terrible. I will say, just be careful with your signs. Your plus or minus is not your trig function. There was something else. Oh, you can check this if you want, but you can take the derivative and do a product rule, not a product rule because it's just sine 5x. It will work out, it's just not pretty. Actually, I want to change this one. I want to make this e to the negative 2x. Yeah, that's more fun. Okay, so here my u is x to the 4th, and my derivatives are 4x cubed, 12x squared, 24x, 24, 0. And when you get to have so many things, it really is important to make sure you keep it all straight. And my dv is going to be, so e to the negative 2x, and then the antiderivative of e to the negative 2x is e to the negative 2x divided by negative 2. And the antiderivative of that is e to the negative 2x divided by another negative 2, so it'd be divided by 4 overall, because negative 2 times negative 2 is 4. And the next one's going to be e to the negative 2x divided by negative 8. And the next one's going to be e to the negative 2x divided by 16. And the next one's going to be e to the negative 2x divided by negative 32. Kind of gross, but it is what it is. So then it's going to be plus this, minus this, plus this, minus this, plus this. The one thing about the e ones is that if it's a negative, you're always just going to change signs like off and on, everyone. Whereas with the sine and cosine ones, the way you change the sign is a little bit less, it's less alternating and more kind of a different pattern. So here they're actually all going to end up being negative because it's plus this times a negative thing minus this times a positive thing. So everything right ends up getting a minus sign overall because it's plus positive times negative minus positive plus positive times negative. So I know everyone's going to be negative, so that's a little bit of less thinking I have to do. So this is going to equal x to the 4th, sorry, negative x to the 4th times e to the negative 2x over 2. I'm just bringing the negative out in front. Minus, I know they're all negative. 4x cubed times e to the negative 2x over 4. The 4's cancel, and I get x cubed e to the negative 2x. Minus 12x squared times e to the negative 2x over negative 8. Well, minus, I already counted before. 12 over 8, right, that's what I'm looking at. 12 over 8 reduces to 3 over 2. So you get 3x, so I'm trying to do too much. Let's just write it out. 12x squared e to the negative 2x over 8, and then minus 24x into e to the negative 2x over 16, and then minus 24 e to the negative 2x over negative 32. Positive all of the minus. Let's see. You'll notice for these e ones, it's always x to the highest power times e to the whatever, x to the next highest power, e to the whatever, x to the next and so on. You should reduce this. Right? I would maybe pull out the negative sign so it's less of a pain in the butt. X to the fourth e to the negative 2x over 2 plus x cubed e to the negative 2x. 12 over 8 is 3 halves. So 3x squared e to the negative 2x over 2. You can pull the like you write this as 1 half x to the fourth e to the negative 2x. You write this as 3 halves times x squared e to the negative 2x. It doesn't really matter. 24 over 16 also reduces to 3 halves. So 3x e to the negative 2x over 2. And 24 over 32, they both have an 8. You can factor out, so that's 3/4, so minus 3 e to the negative 2x over 4. We don't need the parentheses around the plus c. Right, but, oh, inside has to be a plus, because again, I factored out the minus sign to make it easier. I don't think it actually made it